So this next unit is I don't know what it is, like unit 4 maybe, as far as fourth unit. It doesn't matter. What it is we're gonna talk about sequences and series. And I believe the plural of the word series is series. I don't think it's like serieses. That would be really weird. So quickly, let's talk about the distinction between the two. A lot of people use them interchangeably, which is not okay. A sequence is essentially a list of numbers. So you're going to see a ton of sequences today. So sequences, you're going to see commas. An example of a sequence would be something like this: 1, 2, 4, 8, dot, dot, dot. So you see that we're not necessarily performing any mathematics on the numbers, we're just listing them. That's called a sequence. When you put plus signs in between the terms of a sequence, it becomes a series. And so if I wanted this geometric sequence to become a geometric series, then I would change it to be 1 plus 2 plus 4 plus 8 plus dot, dot, dot. That should be pretty easy to understand. And I just wanted to get that out of the way so that it's not a point of awkwardness because I felt pretty dumb when I learned that. And I felt like at some point in my education, I was mad. Like, I feel like I should have learned that sooner. So a sequence is just a list, and a series is a summation of said list. Okay. So having said that, today we are going to study both kinds of sequences. I'm not going to give a day to each. So the first type of sequence that we're going to talk about is called an arithmetic. If you pronounce that word differently as a noun, like the act of doing simple mathematics, you're doing something called arithmetic. But when you use it as an adjective to describe something, we pronounce it as arithmetic. So as an adjective, it is arithmetic, and we're going to be talking first about an arithmetic sequence. So there's two kinds of sequences. This part of the lesson will not take long at all for you guys to understand. An arithmetic sequence is a sequence with a common difference, and that may not make any sense right now, but I'm going to write it down anyways. And as you know from your younger days in mathematics, the word difference refers to subtraction, or quite literally, like if my age is, 52 and your age is 17, the difference between our ages is the physical distance numerically between them. And you can achieve that answer by addition, like reverse engineering addition or subtraction. But in an arithmetic sequence, there's what we call a common difference. And that basically means that in arithmetic sequence, the numbers change by plus or minus. So we can write that down. That'll help us to remember what this means. So arithmetic refers to basically plus or minus. So an example of an arithmetic sequence would be something like this: -4, 1, 6, dot, dot, dot. And can you see what the common difference is in that sequence? 5. It's 5. Very good. Hi. Good job. So you guys figured out that the common difference in this case would be 5. So you'll see this throughout the rest of the lesson, but that means that D, the variable D, you better get used to this guy. D is 5. Okay. What would you say is the first term of this arithmetic sequence? What's the first term? Do you want me to point to it? It's -4. It's right there. That guy also has a name, and his name is A sub 1. Get used to this notation and we start talking about sequences. I won't talk about series at all anymore for the next few days. When we talk about sequences, A sub something, the sub, that's called a subscript. The little number below refers to how far into the sequence am I. And so the initial term or the first term of a sequence we call A sub 1. So these are going to be component pieces that we use for building an explicit formula. The common difference is D. In this case, it's 5. The first term, A sub 1, is -4. Got it? Here's another example of an arithmetic sequence. And we'll do more with that in a minute. Don't worry. If we had like 52, 40, 28, dot, 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 right? The first thing you want to look for is like verify, is it actually arithmetic? Can you see the common difference? How does 52 become 40? And then does that work again for 40 to become 28? I really thought you'd be answering these questions more quickly. I apologize. Yes. So going from here to here, we have to subtract 12. Going from here to here, we have to subtract 12. That's what we call a common difference. It's how much you have to add, or in this case, subtract, to get from one term to its the next guy. So in this case, we would say D, the common difference is negative 12. And what would A sub 1 be for this sequence? 52. Good job. So do you have any questions about that type of sequence? It's important that you ask if you do. Okay. I'm going to introduce to you the other kind of sequence, and then we'll come back to writing the explicit formulas. And it's not difficult. It's just I want to get both sequences out of the way. So the next type of sequence we're going to talk about is called a geometric sequence. And geometric sequence does not have a common difference. A geometric sequence has what we call a common ratio. And the moment you hear the word ratio, you should immediately think of like fractions and division. That's what a ratio is. So the difference between the numbers like 2 and 5 is 3 or negative 3, depending on which way you go. The ratio between the numbers 2 and 5 is a fraction, 2/5. So when we talk about a geometric sequence, let me put an example of a geometric sequence up here, and then you can piece it together. Here's an example of a geometric sequence: 3, 6, 12, dot, dot, dot. You can tell right away it's not arithmetic, right? I mean, it would fail quickly if you said, I think it's arithmetic. Then you could say, okay, well, you have to add 3 to get to the first pair. And then you try adding 3 again, and you're like, yeah, that ain't happening. So clearly it's not arithmetic. And then when it's not arithmetic, we say maybe it's geometric. How does 3 become 6 and then 6 subsequently become 12? There you go. Multiplication. And the moment you realize multiplication is in play, that's how you know you're dealing with a geometric sequence. So the term geometric, just like for arithmetic, we kind of put the words plus or minus. The term geometric is going to refer to times or divide. So when you see you're working with a sequence where each term getting to its neighbor is a result of times or divide, then the sequence we say is geometric. We have slightly different language when we talk about geometric sequences as opposed to arithmetic. The letter D does not apply to geometric sequences. We use the term or the letter R. What do you think R is in this case? Take a shot. Say again? It does stand for ratio, right? And what do you think it is in this specific sequence? The one on the board. It is 2. Very good. R stands for essentially what you have to multiply to turn any term into the one after it. Okay. And sometimes it's going to be a fraction. Hate to break it to you, but not this one. And then the other one is still the same. We still do use a sub 1. That's pretty common. That's sort of going to be a pretty common theme through all sorts of sequences. And again, a sub 1 merely stands for the first term. And what is a sub 1 in the sequence? 3. Okay. Let's do one more example, just getting familiar with the verbiage, and then we'll get into writing some formulas. Easy peasy, I think. Let's do 80, 40, 20, dot, dot, dot. In effect, to put a little bit of extra spice on it, let's make that 40 a negative. Now, I made it red, so hopefully you won't forget to put it there. Listen, it's obviously not arithmetic, for God's sake. If you tried that right away, for 80 to drop to negative 40 would be negative 120. And then if you subtract 120 again, the next term would have to be negative 160. And you're like, yeah, okay, that doesn't work. So then we bail out and think maybe it's geometric. So we ask ourselves, how does 80 become negative 40? Subtraction's out. you divide by -2. Now, here's the thing with geometric sequences. This is the only part of this that might frustrate you, is you're not allowed to divide. We'll say it all the time. We'll say, like, I get it. In plain English, we're dividing by -2. It's easy, but we're not allowed to express it that way. By definition, R is an expression of multiplication. So how does 80 become -40 if you have to multiply? You multiply by -1/2. Correct. Division is not allowed. The word's allowed to come out of your mouth, but you can't use it as like how you come up with R. And then, of course, it works again, right? -40 becoming +20. When it alternates like this and it flip-flops and waffles back and forth, you clearly have a negative common ratio. It's the only way to make it happen. So this is another times -1/2. I don't know why that multiplication sign was so big. Apologies. So times. So in this case, what's R? And what is A sub 1? Good. So there's your introduction to sequences. The R refers to the common ratio, the D refers to the common plus or minus, and the A sub 1 is ubiquitous, like it's everywhere. It's always going to be the first term. Good. All right. So here comes sort of the meat and potatoes portion of this. I'm going to write a sequence up here. Arithmetic or geometric? 100% arithmetic, right? We can clearly see that it's +8 to get from one term to the next. Every once in a while, you might see me or a computer program write 4 terms. If we think that 3 is not enough to show you a pattern, it's hard for me to come up with an example of that. But usually 3 is enough for us to see that it's arithmetic. So in this case, if I asked you a ridiculously simple question like this, find A sub 4, could you? What would A sub 4 be? Could you find A sub 4? What is it? It's 27. And if you don't know what that means, then just get used to it. That's my language way of saying what's the fourth term. A sub 4 is the fourth term. Could you find A sub 5? What is it? Yeah. Could you find A sub 139? If I gave you enough time, right? So this really is the sort of segue or bridge into the rest of this lesson. It's pretty easy to find terms when they're right there. Like it was easy for all of us to add 8 and then add 8 again. And I could have said, what's A sub 6? And we could do this all day. But then I go psycho mode on you here and say, oh, by the way, we're going to skip a whole buttload. And I'm going to ask you for the 139th term in the sequence. There's a mathematical way to do this. And for this, we're going to use something called an explicit formula. And an explicit formula is good for finding an explicit location. It allows me to dive right into any place in the sequence that I want. And if you are a math person, you already are probably thinking ahead of a strategy that you could use to figure out the 139th term. But listen, a fourth grader, if I offer him like a $50 Roblox card or what's that? Is that called Roblox? If I offered them like a gift card to Roblox and said, you got 2 hours, could they find the 139th term? Yeah. They just keep adding 8 and keep track how far they went. They'd be like, I want my Roblox or Robux, whatever they're called. There's a quicker way. So if you think through the strategy, you think to yourself, okay, where do I start? And how many times do I have to jump ahead to get to 139th term? And there you go. I present to you the explicit formula for an arithmetic sequence. And it goes like this. I'm going to write it in green. To find any term in an arithmetic sequence, you take the first term and you add the product of n minus 1 times d. You're going to want to write that down as neatly as you can and probably even put a box around it. And that formula at first looks like a foreign language. And for some of us quicker than others, we look at it, it all just clicks. And once it clicks, you'll look at it and go, I can't believe I ever didn't understand that formula. Let me ask you a question. If I'm standing right here where I've underlined in yellow, if you think of each term of a sequence as like a platform, what platform am I standing on? Number one, right? And if I want to go all the way out to the 139th term in the sequence, hmm, there's a Curious George episode about this. I remember watching it once with my kids. If you want to go from the first platform to the 139th platform, how many times do you have to jump? Exactly, which is where this n minus 1 comes from. Is it makes sense, and you say, wait, if I want to go to the 139th term, I really only need to do 138 jumps to get there. And if I'm on these platforms, how many numbers am I changing by every time I jump? Which is where the D comes from. And of course, the A sub 1 is here because you got to start somewhere. So having said that, let's write the explicit formula for this particular arithmetic sequence up here at the top of the board. So it's going to look like this. We're going to say A sub n equals what? What goes first?
Oh, sorry. 3.
3 plus,
Right.
in this case, n minus 1 times 8. Now, I appreciate that you're jumping ahead of me and putting in the 139, but as far as the formula is concerned, this is the explicit formula for this particular sequence. And now if I said, hey, find me the 139th term, you would just grab a calculator and say, give me a second, and you would put 139 right there. You can use this for anything. You can predict the 10,000th term with this. And then you just go, oh, easy. I'll just type into my calculator, 3 plus 138 times 8. What is it? Did anybody type it in? In case you were wondering, it's 1,157. So the 139th term would be 1,157. Got it? Does that match you? Did you type in 3? Oh God, I didn't type in 3. Hold on. 3 plus 138 times 8. I typed 53. It's 1,107. Whew, I'm so sorry. I must have had a 5 already on my calculator. That's why you should always hit clear there, people. All right, let's practice writing explicit formulas real quick. I'm going to give you another sequence. Are you ready? 4, 10, 16, dot, dot, dot. And here we go. A sub n equals what? What goes first? Thank you. First term plus. And then in these parentheses, you're always going to put n minus 1. Don't put numbers in there yet. You put numbers in there when you want to use the formula. And then what am I going to put over here? Just like that. Look at you. You just wrote an explicit formula for an arithmetic sequence. The two things you need are where does it start and what does it jump by? Easy. Let's do another one. Let's do 512, 499, 486. We're not scared. A sub n equals what? 512, starting point, plus what? Always n minus 1. Good for you. Times what? No. Negative 13. I like to put the D at the back like that in parentheses when it's a negative. I don't feel comfortable writing negative 13 because it could look like a minus. So I usually will leave the D out like the 6 up there if it's a positive, but I like to enclose it. You can always enclose it to be safe. Do you have any questions about how to write the explicit formula for an arithmetic sequence? Okay, so the logical place to go now is finally, how do I write the explicit formula for a geometric sequence? So the formula for explicit formula, so I'm going to write this down for you. The explicit formula or a geometric sequence is a sub n equals a sub 1 times r to the power of n minus 1. And I wanted to start class the way I did today so that the letters R and A sub 1 don't take you aback, that you don't think that that's some weird thing. You understand now that R is just the amount that we multiply by, and you understand that A sub 1 is where we start. So I'm going to write you a geometric sequence. We're going to write an explicit formula, and then we're going to predict some random term. So let's do 3, 9, 27, ... You can see it's geometric because it's obviously not plus, it's clearly multiplied. So in this particular sequence, what is R?
3.
3. And what is A sub 1?
3.
Also 3. An unfortunate choice maybe on my part to have them be the same. We'll do another example after this. So to write the explicit formula for this particular sequence, we would say, okay, any term is, that's what A sub n stands for. It's just I'm leaving it open. Any term is what? What goes first? 3 times
3.
times 3 to the power of
And
n minus 1. Again, don't get ahead of yourself. Don't go changing n minus 1 into something. That's for later. If I said to Lauren, then, okay, so good job. You wrote me this sequence. Now go find me the 13th term. That's when she says, okay, I got you. Now what I'm going to do is I'm going to take this formula that I wrote and I'm going to change that into a 13. That's when we put it to use. And that's going to be a lot. So that's going to be 3 times 3 to the power of, what would my exponent be? 12. Then that comes out to 1,594,323. So obviously geometric sequences are going to behave a lot more insanely than arithmetic, because when you're dealing with exponential change like that, things go a little ham. They go crazy. All right, let's go again.
So when we answer, we put like.
I would write it like this. I knew I should finish that, and I'm sorry that I didn't. I would say that A sub 13 is equal to 1,000,000, I don't know what that was, 594,323. Maybe we got one of them poltergeists in here. Did you hear a noise over there? Okay, yeah, me too. Is that better? Yep. So that's how you would answer it. A sub 13, A sub 10, or whatever it is you want to say. How about this one? The tasks that are going to be asked of you are one of two. I mean, to be honest, I mean, and eventually we'll morph. Once our comfort level is in, bless you, once our comfort level is off the charts, then we'll start morphing this into some other ideas. But for today and tomorrow, the idea primarily is write me a formula, tell me what a certain term is going to be. Those are the two big things for the day. So step one is let's write the explicit formula. And that's always going to start with A sub n. And here we go. What goes first?
400.
400. First term should always lead the way. But remember, since this is geometric, we're not going to do something stupid like put a plus. We're going to put a times. And then I'm going to put some parentheses in this case. And I would tell you that you should put your R value in parentheses when one of two conditions are met. If it's a fraction or if it's a negative. Or do it all the time. Like I told you on that last one, if you just want to parenthesize every time, make it a thing. You can never go wrong. Practice safe math like it's never a bad idea. Got it? Anyways, what is R in this sequence?
1/2.
It is 1/2. And we very specifically addressed this earlier in the lesson that, remember, we're inclined to say we're dividing by 2, but we understand that we're multiplying by a fractional value. Times a half, times a half, so on and so forth. So we're going to stick 1/2 right in there. And then what is our exponent going to be?
Mhm.
N minus 1. And again, that's open-ended. We leave it there. And the question becomes, okay, so as a kid who's going to use, or not a kid, as an adult kid, whoever, I'm going to use a calculator. And again, I won't insult you by saying what's a sub 4? It's 50. What's a sub 5? 25. What's a sub 6? 12 and a half. Like, I'm not going to do that. I'm going to ask you for something that's a little bit more outlandish, like, okay, find a sub 24. And could you? Yes. Could a dedicated fourth grader find it? Yes. Give him or her a calculator and they just start dividing by 2 and keep track of how far. And I got you right here. But we want to go right there. That's what the explicit is for. It's just take me right where I want to go. And so to find a sub 24, we're going to type into our calculators. And I'm going to show you how I would type it in. I'm going to type in 400 times 0.5 to what power? 23rd. So your power that the number that you use in the formula is always going to be one less. And again, that comes back if you're not ready to understand this yet, you will be. If you're on the first platform and want to get to the 24th, you don't jump 24 times because you're already on the first, so you only jump 23. That's why we keep having this stupid -1 thing. And then it's going to be ugly, probably. I didn't think this through, but let's see, 400 times 0.5 to the power of 23. And you're going to see an -5 on your calculator screen, probably. And so let's talk about what that means, since things like this are going to be happening to you. So my calculator says 4.76837152. But then the confusing thing is afterwards it says E-5. Do you guys know what E-5 means? It means scientific notation. Very good. It means times 10. Good job, Aiden. Times 10 to the -5th. And even that, you might say, well, that doesn't do me any good. Let me give it to you in plain English. What does it really mean? It really means take this decimal place and move it 5 places to the left. So whenever your calculator says E, it's just run out of the ability to put the number. You guys see E's ever on your screens? When you see it, it's just a decimal movement, scientific notation. So if I move that decimal 5 places to the left, then I have to add 4 zeros. So it's going to be 0.0000477. I'll round a little bit. Whatever problems you're working on, like Delta Math today, whatever anyone that gives you, they'll tell you what to round to. And in this case, no one would say round to the nearest 10 millionth like this, but still, that works. I think that is everything that I had to say. I had some examples, and I got to be honest, I went completely off script and we didn't do a single one of my examples. Go figure. So do you have any questions about the difference between the types of sequences or how to write the formulas or how to use the formulas? Great. Well, look at us. We got 10 minutes. Your assignment is on Delta Math. It's like assignment 35, I think. And it's a combination. I think the first section is just writing the formulas. And then the second section of problems is writing the formulas and then using them to find values.